this next slide is going to be about mandatory air leakage requirements. Okay, so this particular slide, okay, since we're back from break, right? This particular slide, we're going to start talking about air leakage control, right? And so now there is a new standard that is used to perform the building leakage test set, okay? And that's what this is, ASTM E779 or ASTM E1827, okay? These are your new testing procedures. Now, let me go forward here a second. So now, the old code had 5 air changes per hour. That was the requirement. This new code has 3 air changes. So it's a big significance in this change here now, guys. So in these is the next slides going forward are going to explain why these changes are so significant, okay? All right, mechanical ventilation, okay? Mechanical ventilation, where the air infiltration rate of a dwelling unit is 5 air changes per hour or less when tested with a blower door at a pressure of 0.02 inches, water column, 50 pascals. In accordance with section N1102.4.1.2, the dwelling unit shall be provided with whole house mechanical ventilation. All right, so now what does that mean? Well, back in 2012, sometimes, enforcing the code, if we gave it to you all at one time, believe me, you guys would probably have a fit. It would be some drastic changes you would have to do, right? So we didn't exactly enforce it, right? But if you put it there, then we were happy with it, right? But now, because we're at these 3 air changes, which is a whole lot lower, then you guys are going to have to show us how you are mechanically ventilating the dwelling, all right? So there's a particular, these slides tell you about the mechanical ventilation rate and how you can be compliant with that ventilation rate, okay? This chart right here. Now, what a lot of you guys do, you show us this chart, but you don't highlight the particular column that you are selecting. So just showing us this chart does not make you compliant. Same thing with the bottom chart. You have to show us by highlighting it or some other means which particular air rate that you're selecting, okay? Now, on top of that, when you are mechanically ventilating a dwelling, there are various ways you can do it per code. So you can do exhaust only, you can do supply only, or you can do a combination of both, okay? Now, they have their pros and cons. So exhaust only, then of course you are negatively pressurizing the home. And you're forcing outside air to come in through whatever leaks still remain in the house, and you're negatively pressurizing the building. Likewise, if you do supply only, you help to push air out, but you still bring in outside air. Now, there's something called indoor air quality that we are really concerned with when we get down to these air changes below 5. And right now, like I say, 2017 code says that your air changes shall be 3, okay? 3 air changes per hour. So that means that you're going to have a whole lot of stagnant air inside your home. This indoor air pollution can really affect children and older folks with respiratory problems. I mean, really, you're going to have to find some means of venting this air, exchanging this air. The inside of the house can be just as dangerous as air on the outside, okay? Matter of fact, even more dangerous, because as you seal and tighten up the house, as we are doing now, the house ain't as leaky as it was. So there's no chances for these off gases and these pollutants, these indoor pollutants, to get out like it used to be. So now, by sealing the house tighter, you are now sealing in bad air possibly. So you're going to have to find a way to exchange that bad air with good air, right? Now, Though it's not in the IRC yet, we're hoping that maybe the next iteration of the IRC will bring into some new, will add some new technology that has been out for a while now, right? So one of these new technologies is ERV, an energy recovery ventilator, right? So it provides what's called a balanced way of ensuring indoor air quality. Now, it's a little more expensive, but it does a better job, right? And there's some other ways of doing it also, but at this particular time, the ERV, in my humble opinion, is one of the best ways of ensuring indoor air quality at this time. Now, we accept any other way, exhaust only or supply only, just as the RRC says. But if you're going to do that, you're still going to have to show us how you're going to control that mechanical ventilated air. So there has to be a control mechanism to ensure that your damper that's bringing in that outside air opens at the rate that you are designating on this table, okay? So if 45 CFM is supposed to come in, then you got to have a damper setting that allows 45 CFMs to come in. If you are doing it intermittently or whole house ventilation, there are certain control mechanisms that must be in place to ensure the right volume of air comes into the home. Now, the other thing is that when I look at some of these designs, let's say, for instance, if you have 2 units in your dwelling, or even 3, but okay, we'll just go with 2, that's easy. Then your whole house ventilation is based on the whole house, of course, but now the ventilation requirements is split between these 2 units depending on the volume of air that they're serving, the rooms that they're serving, the amount of space that they're serving. So if unit in the basement, say like if you had a 3-floor structure, you had a basement in the first floor, and the unit in the basement was serving the basement in the first floor, then its its whole house ventilation rate is based on the first 2 floors and the people that reside in those areas. Now, the unit that's on the top floor, that's only serving the top floor or the second floor, its whole house ventilation rate is based on that square footage and the people that reside in that portion of the house. So combined total, they will make up the whole house ventilation rate, okay? So you can't take and bring in the whole house ventilation rate on both systems because it's going to be too much, okay? You have to balance that rate per system based on the areas that each one of them are serving, okay? So just keep that in mind. This is very important now. This is one of the parts of this training here that I really want to hit home, that you guys understand, man, because it's indoor air quality and it affects everybody. It affects your comfort level. It's a safety factor. As I said, we're sealing these dwellings a whole lot more than what we did previously, and we got to pay attention to that. We have to now bring in mechanically ventilated air to help flush out the old stagnant air, okay? So I hope I beat that dog to death. And if you guys have any questions, just give me a call. We can discuss it. As with this entire slide, we're available to discuss it, to clear up any things that I wasn't able to clarify during this training, okay? All right, so now, rooms containing fuel burning appliances. Now, this is new, and this still goes back to mechanical ventilation, okay? So, it says, okay, rooms containing fuel burning appliances. This states where open combustion air ducts provide combustion air to open combustion fueling appliances. The appliance in the combustion air opening shall be located outside the building thermal envelope or enclosed in a room, isolated from inside the thermal envelope. So existing buildings undertaking a level 3 alterations at 80% of aggregate area must comply with one of the following. So here's the easy thing, guys. It's easy if you do this, right? It says new equipment and appliances shall be sealed combustion. So that way you ain't got to worry about the rest of this right here that I'm about to discuss, all right? So if you have sealed combustion furnaces or sealed combustion water heaters, then you're good as far as this next requirement goes. But if you don't, if you choose to have atmospherically vented devices, then you're going to have to show us how you are controlling air from the carbon monoxide and backdraft issues that are associated with atmospherically vented appliances. So you'll have to construct the room to isolate it from the rest of the house. So one easy way of doing it is just putting it on the outside of the house or outside the thermal envelope. That way, whatever backdrafts or CO issues that may be related to that atmospherically vented device don't blow back into the conditioned space, the living area, okay? Now, if you have no choice and you are locating that combustion, the atmospherically vented device inside the conditioned space, then you have to isolate that particular closet, that particular space that it's in, okay? Let me go back here. So now that means that there are certain test requirements that go along with that. And believe me, it's a monster. It's easier, guys, just to use sealed combustion devices, okay? That way, direct vented devices. That way you ain't got to go through all this right here. Because believe me, you send me through a hard, it's a hassle for me to review these plans when you're doing this, okay? So do me a favor. All right. Now, we're talking about trade-offs, and it says the maximum fenestration U value and SHGC are mandatory. And we're still talking about mandatory requirements here. So the area-weighted average maximum fenestration U factor permitted using trade-offs from section R402.1.5 or R406 shall be 0.40 for vertical fenestration and 0.75 for skylights. Now, REScheck is that particular program or software that you guys use for trade-offs, right? Now, at this time, REScheck does not include our local 2017 code updates. So if you give us a REScheck form, then we can't accept it for a trade-off. You can give it to us now, but if you try to use it as a trade-off, we can't accept that because it's using 2015 code values, not the 2017 code values here in the district, which are more stringent. So it will give you a false indication of your percentage of being above grade, all right? So now, things are in the works with REScheck to hopefully get our local code requirements entered into a version of REScheck that you guys can then use, okay? We're not there yet, but hopefully, before this year is out, then we will be there. But until then, we do not accept the 2015 REScheck for trade-offs, okay? Cool roofs. Now, this is, a lot of this stuff ain't, well, this portion isn't new. It just came out of the building code, but so we're going to start hitting you up for this right here now. And it states that roof coverings for slope roofs less than or equal to 2 units vertical and 12 units horizontal, 17% slope or less, for buildings and covered parking shall conform to this section. Now, I'm not going to read all this with you or for you, and it says that it shall have a minimum 3-year age solar refractive index, SRI, of 64. So, in order to be compliant with this, we're not going to accept a statement. We need to see your product data for your roof covering that says, in fact, that this particular material has an SRI of 64 or greater, okay? I'm going to say that again. We're not going to accept a no for compliance with this. The particular material that you are using to cover your roof must be in compliance with this SRI 64 grader. So show me a spec sheet, show me the specs for the roof products that you're installing, and we're good. Okay? So these sheets tell you a little bit more about the SRI, you know. There's certain ways of measuring and whatnot. I'm not going to go too far into that. I just put it here because this is part of the new code 2017 code update. All right, so this next section we're talking about mandatory requirement. We're talking about mandatory requirements for systems, right? Sections R403. All this stuff is mandatory, meaning that ain't no trade-off for this right here. You guys got to, you know, comply with this stuff, okay? Heat pump, supplementary heat. Now, this has been a pain so far for you guys to understand. This was in the 2012 code cycle. We couldn't enforce it then, but we're enforcing it now. So it says heat pumps having supplementary electric resistance heat shall have controls that, except during defrost, prevent supplemental heat operation when the heat pump compressor can meet the heating load. Plans must include heat pump balance point for compliance. The auxiliary heat temperature, that point or temperature setting that starts the auxiliary heat is crucial to system performance and energy savings. The temperature shall be displayed on the equipment schedule for compliance. So here's how you are in compliance with this particular measure. Now, there's basically two ways, and it may be more, but let's just say two ways that we see most of the time. So one, and the easiest way, if you ask me, is to purchase one of these thermostats that automatically detect the balance point, okay? So far, I only know of one that I've researched, and yes, it works. And that's the Nest thermostat. It has the ability to automatically detect the balance point, okay? So far, all the rest of the thermostats that you guys try to send in and say that are that automatically detect it, they don't. And I know they don't because I call the manufacturer, and we have a discussion. Sometimes even their spec sheets almost say that they do, but when you call them and talk to them, they say, nope, it doesn't automatically detect it. It's a manual input. So far as we know right now, the Nest is the only one that does that automatic detection of the balance point. Now, the other way of showing what the auxiliary heat temperature for your heat pump should be is, now REScheck has its manual J software shows you the balance point. So that means that the manual J information entered for that particular system, the data must be entered properly so that the proper balance point will show. You can take that balance point from the manual J report and use that as the temperature for the auxiliary heat, okay? So why is this important? As I said before, because it saves you money. If you don't set the heat pump auxiliary temperature, it's at a manufacturer default when it's installed by the technicians, okay? Now, if you don't tell them what to set it at, then it's the default for this particular region, which may be around 45 degrees, which means now your auxiliary heat temperature come on, it's going to turn on at 45 degrees. But the heat pump can still meet that load at 45 degrees. So you don't need the auxiliary heat. So this is why we're telling you that this is why this is a code requirement, so that the heat pump, when it can still meet the heat demand of the system, then you don't need auxiliary electric heat, okay? But when it can't meet that demand, then that temperature setting, that balance point, needs to be identified in the setup for the thermostat, okay? So we want to make sure that the inspector, if they go out there and happen to take a look at this auxiliary heat temperature, then it's set in accordance with what's on these plans, okay? So that's one of the reasons why we want you all to start showing that, okay? It has to do with energy savings and performance, okay? Now, here's the thing about heat pumps. Sometimes, and heat pumps can be figured with electric heat or with gas heat. So what happens sometimes, so guys, and you confuse us with this right here, and you know, I'm gonna hit up on this a little bit here because, you know, when you start designating or how you start naming your furnace and air handler makes a big difference to us because it sends us down a rabbit hole sometimes looking for information that's not necessarily there. So for example, heat pumps can have auxiliary heat of a furnace. You can have a furnace connected as auxiliary heat. That's all I'm saying, right? But most of the time, it's electricity. But you guys will show us information that says it's both. It's electric heat and it's a furnace. So that confuses us, right? So by the time we get our thoughts together, by the time we get to the mechanical and start looking at the manual J and all that stuff, then yeah, we may figure out that, okay, no, there's no furnace connected to this system. It's only the auxiliary heat is electric heat and electric heat only. And that's cool if that's what it is. But you provide confusing information to us, and we may spend an additional half an hour trying to sort through the plans to figure out, is this a furnace for the auxiliary heat or is it an electric resistance heat, okay? So you gotta be real clear when you guys start identifying these heat pumps. Now here's one designation that you use that, like I say, I know we can't stop this because, you know, the industry, you use different words to mean the same thing sometimes. So from my perspective, being an HVAC technician, when I see the designation AHU, air handler, then I know I got a heat pump because an air handler is nothing but a big fan, okay? Now, if you are installing a furnace, okay, then you say it's a furnace because you have a furnace that sits on top of a blower motor which has a fan. But the designation for that type of system is a furnace, and then you have an air conditioner on the outside. If you have a heat pump that has a furnace, then you just tell us that, you know, furnace, heat pump, auxiliary heat is provided by the furnace. Then we're good. But if you say you got an air handler, and then you show us that you got a furnace, then it just confuses us, man. So that air handler designation is used throughout the industry. I know me telling you ain't gonna change it, but I really wish you would, because you really saved me a whole bunch of time scrambling through your reports or your plans for an additional 20, 30 minutes trying to figure out what kind of system you got, okay? So that's my little 2 cents on that. I know it's not going to do any good, but hey, there it is. All right, where's the supply? Okay, here's the other mandatory thing about supply and return ducts outside the building. Thermal envelope shall be insulated to R8. Exception, where ducts are less than 3 inches in diameter, a minimum bar 6 is required. Okay, so we know where the thermal envelopes are at, right? They are in your attics if your attic is unconditioned, or in your crawl space if the crawl space is unconditioned. So in either of those cases, if those spaces are unconditioned, then we expect to see that your supply and return ducts are insulated, okay? Next slide, duct sealing, mandatory. Got to seal those ducts. Joints and seams to comply with IMC or IRC. Exceptions, air impermeable spray foam products shall be permitted to be applied without additional sealed joints. And for ducts having a static pressure classification less than 2 inches of water column, So this is pretty much a gimme. We know that you guys are going to seal the ducts, but as far as code compliance goes, you have to at least still tell us that, okay? Duct-Tightness Test. Now, this is different than the old Duct-Tightness Test. So you guys have to change your boilerplates. And I've been catching some of you guys on this now, right? So just keep that in mind, okay? Some of you guys, even though your particular project may not require a duct test, I know that you have a boilerplate that you use, and that's fine, but please correct the boilerplate to reflect this language right here, okay? That way you won't get yourself in trouble with me or any other reviewer, okay? And here's a picture of a duct tightness test at Rough-In. You know, this is what these guys do. And, you know, if you guys were smart, this is where you would start this set, because then before you put the drywall up and all that stuff, you can catch those leaks in the system before you put the drywall up, and it's going to cost you more money to go back and cut holes in the places and seal stuff that could have been sealed at this particular point had you done a duct leakage test at Rough-In, okay? Everything is still exposed. You can catch all the gaps that you need to catch, and then at the final, when you do the final duct leakage test, when everything is closed up, if it is any leakage, it should be very minimal. So there again, you're good to go. But this is where this starts right here at the Rough-In. Before you put in your drywall, do a duct leakage test. Do yourself a favor, okay? Mechanical ventilation mandatory. Well, that goes back to what we were talking about earlier about mechanical ventilation for these air changes that are 5 air changes or below. Okay, so that's all we're talking about here. Okay. Now the next citation, mechanical ventilation system fan efficacy. Mechanical ventilation fans shall meet the efficacy requirements of Table R403.6.1 or be certified to be the most current version of any star. Now here's what you guys do. See this slide here? You show us this slide. Now, just in case you didn't know, we know this slide, okay? So by showing us this slide does not meet compliance. You have to tell us how you meet compliance. So we have to see the CFMs and the wattage data for your fans. That's how efficacy is calculated, okay? Or give us a spec sheet and supporting docs that shows that your fan is an Energy Star fan, okay? Then you're good to go. Other than that, though, you're going to have to show us CFM and wattage data on your fan schedule so we can calculate compliance, okay? Now, a lot of guys, a lot of you designers, and I don't mean always say guys, it's just a figure of speech. I don't want to get anybody all, ruffle anybody's feathers, but a lot of times you guys show us an exhaust fan for the bathroom only, but you also have a kitchen fan, and you leave that out. Okay, just ensure if you got a kitchen fan in there, you have to show us the information for that fan also, or provide a spec sheet and supporting docs, and then we're tracking. Okay, but for compliance, this table does not work. All right, do not take this table off your boilerplate. Get rid of it. We don't want to see it. Okay, it does not meet compliance. Understand? Only thing you got to do is show us the CFM and wattage data, or show us the spec sheet and supporting docs, and we're in the house, okay? All right, so now we're talking about systems. Systems serving multiple dwelling units shall comply with sections 6 and 7 of, it should be the commercial NG code, okay? Not the residential. I thought I changed that, but it should be the commercial NG code in lieu of section R403, right? So, now, this is kind of a heartburn for me, and we still haven't worked this out, because the mechanical code states that recirculation of ventilation air shall not be recirculated. Ventilation shall not be recirculated from one dwelling to another or to dissimilar occupancies, right? Then it's another portion that states that thermostatic controls must be separate. So, and I'm saying that to say this, right? there are a lot of what we call ADUs, accessory dwelling units, that share an existing, the system that's already in the house. So, and that may or not be okay. It all depends on the setup of the premises. So here's a for instance. You have an ADU that's in the basement, and the main structure has the first floor and the second floor. But the heating system for the entire structure, the heating and air conditioning system for the entire structure resides in the basement. Okay, so now, that thermostat for the main structure in the basement is usually on the first floor. So now you have the person who may be renting the basement, he has no control over the thermostat. The thermostat is controlled by the conditions of the upper floor. So now, he's at the mercy of the first floor thermostat setting, which may not be the right setting for him or her. So there's some issues, and hopefully we can get this thing worked out, but that's part of it, right? If you're renting out your basement to somebody else, then you should have a separate system in there. The code kind of allows us to enforce that to a certain degree, but it all depends on, I guess, whether you're renting or not, whether it's what's called a mother-in-law suite, so we got to work that there out. But that's what this particular section supposedly helps to work through, okay? All right, now we're talking about swimming pools. Outdoor heated pools and outdoor permanent spas shall be provided with a permanent operable vapor retardant cover or other approved vapor retardant mediums, okay? So that's new because the operable word is operable. At first it was just vapor retardant cover. Now it's got to be able to roll on and roll off, so to speak, okay? So that's that one. Okay, lighting. Lighting used to be 75% of lamps permanently installed would be high efficacy. Now it's 85%, so change your boilerplate, okay? Additional efficiency package. Now this is what gets me about this. Okay, now this only applies to new buildings, y'all. Only new buildings. So you have 4 choices. One being enhanced HVAC performance. The other, enhanced building envelope. The next one is enhanced air leakage and heat recovery ventilation. And then the last one is enhanced water heating supply. So what you don't have to do is be compliant with all that stuff, like some of you try to do. Then, no, you just have to choose one. And on the new EVS, that's where you tell us which one that you're choosing, okay? So these next slides show you how you are compliant for these things. So for the additional efficiency package for the HVAC system, these are the requirements. It has to be at least 15 SEER. Now, most newer units meet that anyway, but you still got some throwbacks, they're still out there that are selling 11 SEER and 14 SEER or something like that. So it's got to be 15 SEER or above for your air conditioning systems, or if you got a gas-fired furnace, it has to have an AFUE greater than 90%. So you can see the rest of it. For a heat pump, it has to be a 17.1 EER, and it's greater than or less than greater than or equal to 3.6 COP, okay? Okay, so these are the requirements if you are choosing to choose the thermal envelope enhanced efficiency package, right? These are showing the minimal values that are required. Windows got to be 0.24 instead of 0.30. So everything has been kind of reduced down to a certain degree, right? R19 plus R10 continuous for the cavity in the external insulation, or R13 plus R15 continuous. So everything is stepped up a little bit. Get what I'm saying? Air leakage, enhanced air leakage and heat recovery for the enhanced package. Now, from 3 air changes, you're saying that you're going to take it down to 2 air changes. Boy, that's a tough one, but if you do that, you are really going to have to now take care of that mechanical ventilation I was talking about earlier, okay? It's really important then. So if you choose this particular way to go, you better believe you're going to be bringing in mechanical ventilation, and it's going to have the proper control methods, all right? Okay, and this is the setup for the water heater, right? Refrigerators, clothes washers, whatever, right? Gas storage water heater has to be have an energy factor of greater than or equal to 0.90. Tankless water heaters, 0.95. And electric water heaters, 2.2 energy factor, okay? So that takes care of your enhanced additional packages, okay? Now we're going to talk about the ERI in a little bit more detail, but not a whole lot. But so anyway, the compliance with this measure requires that mandatory provisions identified in sections R401.2 and R403.5.3 be met. The building thermal envelope shall be greater than or equal to the level or efficiency in SHGC in Table 402.1.2 or 402.1.4 of the 2009 IECC. Boy, what a mouthful. Okay. So here's what you got to remember about all this stuff. Let me go to this next slide here. So these are some of the requirements of the 2009 R406.2 table for the insulation and U factors that are required for the ERI compliance. Now, this is showing you a little bit more information about it, but the main takeaway here is that you see that 54? That's what you got to meet. Compliance based on an ERI analysis requires that the rated design be shown to have an ERI less than or equal to 54 when compared to the ERI reference design, that being the 2009 house, right? Now, as I said earlier, which I know you guys don't remember, so I'm going to say it again, engagement of a HERS rater is required at this time prior to our approval. So if you choose to go the route of ERI compliance, you're going to have to get a HERS rater to do a rating, rate your design, and show that your design meets the ERI target of 54 or less, okay? That's the takeaway of all those slides, all right? Okay, existing buildings. This isn't new. It used to be in existing building codes, but we moved it over here since it has to do with energy. And it talks about additions, alterations to existing buildings, right? And it also has something in here about the ERI too, in that the addition shall be deemed to comply with annual site energy uses of the addition in the existing building, and any alterations that are part of the project is less than or equal to the annual site energy use of the existing building when modeled in accordance with section R406. The addition and any alterations that are part of the project shall comply with the section R406 in its entirety. So, what is all that mess saying? Okay, it says that additions can be compliant via the ERI if they comply with R406. So if the original house energy usage is 10,000 kilowatts annually, and now with the new addition, the original house plus the addition equal 2,000 kilowatts per annual usage or less, then it's in compliance, okay? That's what this is saying, you know? So just keep that in mind. And I know you're probably not going to choose the ERI anyway, but just in case you do, there you go. Okay, for alterations, building envelope assemblies that are part of the alteration shall comply with those sections. I'm not going to read them all out. And the exception being, the following alterations need not comply with the requirements for new construction provided the energy use of the building is not increased. Storm windows installed over existing fenestration. That's your exception. So, other than that, yeah, they got to comply. Okay. Alterations affecting 80% or more of the aggregate area of the building, existing exterior walls, ceiling, and floor assemblies that are part of the scope of work of the alteration but are in an existing building undertaking a level 3 alteration affecting 80% or more of the aggregate area of the building are required to comply with the following minimum insulation requirement. Man, what a mouthful. So don't forget what so the 80% level 3 is only for energy. It's not for any other discipline, no any other trade. The building code still says 50% or above is level 3. But as far as energy goes, we decided to give you guys a break at this EVS requirement or energy worksheet requirement because, we understand that sometimes it can be a little cumbersome because the EVS is required for new construction, additions in level 3. So we bumped the level 3 up so that you don't have to do it, for alterations that are only 50% or over, right? Okay, we stepped that up to 80% or more so that you won't have to, comply with anything less than what we call a full gut, basically, okay? Now, I had one guy send me this one right here, right? So on this top one says, existing exterior walls shall be insulated to a minimum of R7.5 continuous insulation or R13 cavity. So he thought that was the requirement for existing walls. So, but now what we're saying here though, guys, is that if the portion of the wall, okay, out of 80%, there may be 20% of the wall that's not being altered at all. But what we're saying is that those particular portions of the wall must be insulated to a minimum of R7.5, okay, continuous insulation, or R13 cavity. That's what we're saying. That portion above 80%, that 20% that ain't getting affected at all, got to at least have R13 in there, okay? That's what we're saying, all right? Everything else, you can read it. It's not a big thing, all right? Okay, this is about the level 3. I was just talking about level 3 alterations affecting 80% or more of the aggregate area of the building must comply with air leakage requirements and procedures per section R402.4.1.2. Air leakage testing, that's all. Okay, we're still on the mandatory requirements, y'all. Heating and air conditioning systems. New heating and air cooling and duct systems that are part of the alteration shall comply with sections. I'm not going to read all that. Okay. Exception where ducts from an existing heating and cooling system are extended. Ducts with less than 40 linear feet in unconditioned space shall not be required to be tested in accordance with section da-da-da-da-da. So we understand, guys, if you are just extending duct work, that you don't have to do a duct leakage test for that entire system if that particular extension is only 40 feet or less, okay? That's basically what we're saying with this right here. Also, service hot water systems, new service hot water systems that are part of the alteration shall comply with section R403.5, okay? So you got to be compliant with the old code, okay? Or the new code.